Hello everybody, and welcome to another video for our series creating a REST API with Phalcon v6. We have done quite a bit of work in the previous videos. We've bootstrapped our application to offer users when the relevant ID is sent to the relevant URL. We have our hello world, we have some middleware, we have JSON responses and all that. But now it's time to start working with JWT tokens. For those that don't know, JWT is JSON Web Token. It's a really long string split into 3 parts, and you can tell which parts those are by looking at the 2 dots that exist in the middle of this in a couple of parts of the string. And there is a mechanism where the actual token gets decoded and then validated with regards to what information it contains. The information that you can store in the token is both in the headers and also in the claims. These are different types that you can set up. There are certain types that come as standard, if you like, and then there's custom types. We're going to utilize all of them, and we're going to create a JWT class that would allow us to parse the tokens but also generate them for users. The goal is to create a login endpoint so that when users send their username and their password, they can receive a token back, and then using that token they can interact with our API and, let's say, request a user, request a company, insert a user, insert a company, or whatever. Of course, we don't have companies here yet, but that is to do for the future. So in order for us to do all that, we have to be able to parse the tokens. As I mentioned, that's the purpose of the class that we're going to create. A couple of other things on the schedule for today. We're going to create a class for cache, which will extend the Phalcon cache with a few more modifications of our own. I'd like to refactor the EnvManager and make it a non-static class, and I'll explain why that is. We're not going to need anymore the hello, so this service here, and once we add the login functionality, then what we're going to do is we're going to introduce a full set of middleware classes that would allow us to stop execution if certain things do not exist in the token that we're receiving. For instance, one middleware could very well be if the token is not present. But all that will come a little bit later. Let's get started with the class that we want to create, the JWTToken class, and that will be the class that will either generate or parse tokens for us. Before we go into that class, I'd like to create an enumeration just to make sure that we have all the claims set up the way they should be. Let's put F5. And this one will return a string. And let me copy the contents. There's no point in you guys seeing me just typing the same thing. So as you see here, the JWT token has, and these are built in, by the way, has certain headers, which will be the type of the token, the algorithm, and the content type, and also you have the claims, audience, expiration, issued at, ID, and so on and so forth. But we also have these 2 new claims that we want to utilize in our application, and one of them is the UID, the user ID, the user ID from the database of the person that this token is targeted, is sent back. And then when we receive it, we will check this user ID according to what else is stored in the token, just to make sure that you are who you are, so to speak. And the refresh ID is for a refresh token later on. This one we will tackle it probably next in the next video, the refreshing of tokens. And it's a different mechanism where certain applications will send you two tokens. One is the normal token that will expire, a minute, an hour, 4 hours, or whatever, and then a refresh token that usually will last you for a day. And when the time comes and you cannot use the main token, if you like, and that token has expired, then you can use the refresh token to get a brand new one, to refresh it, so to speak. So this is kind of like a mechanism that is usually used. So for our JWT token, we're gonna create it in here. And what we need is a few things. So we need a way to excuse me, we need a way to have a database user and get the token from it. So parse the database user data and then create a token for that. We need a way to get a token object, and this is the object that gets created once the token gets parsed. What we also need is to extract the user from a token. And finally, we need to be able to validate the token, whether it's correct or not. All right, so I'm just going to write the stubs here of what methods we will need, and we'll go on from there. So we're going to call this get for user, and it will be array, and that one will give us a string. So this one will receive the token from the user. And actually, while we're here, might as well add the PHP stan imports so that you guys can follow with what is what. Import type the user record from user types, and we need the user DB record. And while I'm here, this comes later on. So the get for user will be return the string token, and what we're gonna send, it will be a t user DB record. So this is a well-established active record from the database. The next thing that we need to do is we need to have a way to get the token object. And this token here is an object that comes from the Phalcon security JWTToken namespace. It is an internal part of Phalcon. This JWT functionality, just a note, supports only HMAC. We have plans for the future for more support, additional algorithms, but for now, that's what it supports. And what this token will be here is we're gonna return the JWT token object. Now we need a way to get a user and then to validate a user. So public function get user, and in order to get a user, there you go, that's better spelled. In order to be able to get the user, we need to, this is a database user, we need to be able to do what? what will we need to get the user? Of course, we're going to need the query repository because that's going to be a database interaction. And we need a token because we're going to need to parse the token in order to get the necessary information to construct our query. And what we will return is a database user. It will be this one, TUSERDB record. Actually, no, it will be a TUser record, because if you remember here in the user types, the DB record is the one that comes straight from the database, but the user record is the result of a find one or fetch one, which could be an empty array or a DB user record. So this one here is a T user record because we don't know whether we're going to find this user. Next in line will be the validation. And of course we're going to get a token object. Object. And then we're going to use a user transport. And then that one will return not a boolean but an array. And that array would be the one that I wrote above, T validation error. So this array that will be returned will be an integer as the key and a string as the value. Alright, so that's what we have to do. I'm going to go through this a little bit quicker than normal. I'm going to copy and pasting. I'm not going to be typing much. I will explain definitely what's going on. So a few of the things that we will need would be first of all to get the audience. That's what the token is intended to go to. Who is the recipient, so to speak. And we need to get that from the environment. That's where we store it. In the future, we can certainly store it here in this field, the user preferences that we've created in the past. Maybe store it there as a JSON field and have a different audience, which could be a unique identifier as well for a particular user. But for now, let's keep it in the env. So let's do that, and then what we're going to do is we're going to create a method to generate a token for a user. Private function get token audience. I can spell. And then audience equals EnvManager get audience, and then HTTPS it's just a default that we decide. You can decide whatever you want. And then return audience. So that's my get audience. Now let's do the generation. Now that we have this method, so we're going to call it private function generate token for user, and what that has is an array, which is the user, date time immutable, which is now, date time immutable expires at, and then bool is refresh. The refresh will come into play later, as we discussed, and this one will return string. Alright, and what do we get in here? This one is an actual record for the database, so it will be TDB user T user DB record in order to satisfy PHP stand. Okay, so what we're going to do is we're going to use the token builder from Phalcon in order to create this token for us. And we're going to use HMAC, of course, as the signer because that's the only one that we have available. And we're going to need this one, this builder. And then in here, the signer will be new HMAC. And that's our signer. If you see here, the algorithm is a SHA 512. You can use SHA 256 if you want. So there is a little bit of flexibility there. So let's get our data here. User USR issuer, and then we need token password equals, and then we need token ID equals that, and then user ID equals the USR ID. String and string. I have to get back to this the string for the user. But if you recall, here in the database we did create these three fields, and these were going to be used for the token generation and of course the token signing as well, in particular the password. And the token ID is unique, so nobody else has that particular token. Now that we have this information, let's create the token, and that will be the token object equals token builder. So we need set issuer equals issuer, set audience equals not the issuer, this get token audience. Now we need to set ID, will be the token ID. Now we need set not before. Not before will be now. So this is when you start this. Set issued at, again, now get timestamp, and then set expiration time will be expires at get timestamp. We need set passphrase equals token password, and now we need to add two new claims. Add claim will be JWTToken. We need the user ID value, and that one will be the user ID, and one more, that will be the refresh, and that one will be false. Actually it will be is refresh, that what we have there. And then we're going to wrap this but with calling get token, because that one will give us our object. And now return token object get token. Quite a few get tokens. Let's unpack this a little bit. We're receiving a user from the database, and we're also receiving the now and the expiration time, and whether this is a refresh token or not. We're building a new builder here. We're grabbing the issuer, token password, token ID, and user ID from the database record that we have. And using the token builder, we're actually setting certain things in here, the issuer, audience ID, and so on and so forth. We also add the two new claims. The important thing is set the passphrase. That's a key there. And then once that is done, the get token on the builder returns a token object, and then the get token on the token object returns a string. I mean, too many get tokens, but This is how that works. So where are we going to use this one? If we go up here to the get for user, what we need to do is now equals new datetime immutable. So expiration equals EnvManager get token expiration, and let's put 60 for now. And I'm gonna put a to do check the default expiry. That's for later, but I want to make sure that this 60 is something that is reasonable. I mean, we can do it 3600, but it's fine. It's 1 minute. So now let's put that there. Expires at equals now modify. There you go. And this one is actually int, and we need to make sure that it's an int. So that's our expiry, and now what we need to do is return. This is where we're going to use our private method. This generate token for user. We're going to pass the user. Now expires at, and we're going to leave the refresh token to false. So that's all we have here. So that's how we create the token. When we call get for user for a user in the database, it will just go generate that and give us the token. So now what we need to do is we need to get the user from the token. So let's go back here. We're going to get to the, actually, let's do the object first. All right. For the object, to take a string that was submitted by a user, and we'll take that from the header, the JWT string, and then send it to the parser so that I can get a token object that I can use in my code. That's what we need to do now. In order to do that, I did mention briefly we do need a parser, and it's this one here. We're going to keep this one with null. And the reason I do this is in the case that I need to reuse this class numerous times, I don't have to create the parser all the time. So in the get object, we're just going to have a small if here that would allow us to work with the parser as it comes in. So the parser does throw exceptions. And we're going to create the token validation exception in a minute. So we need try, and then catch invalid argument exception ex, and then down here we're going to have something, and then we're going to return the token object. Okay. So let's say if null equals this parser, then this parser equals new parser, but the new parser needs a decoder. That's it. That's what we need to do. And now we need token object equals this parser parse token, and then down here return token object. And in here we just need to throw a new exception, and let's create the exception for a minute. But before we do that, this is the way this thing works. If we do have a parser, that's fine. If we don't, just create a new parser with a new decode class, the decoder, and then all you have to do is just send the token into the parser, into the parse method. If an invalid argument exception is thrown, then catch it and just send an exception of our own outside. So let's go to our exceptions and then go here. Let's copy this and let's call it token validation exception. I guess we can just leave it to the invalid argument. What I also want to do is just a small deviation. I'm going to create a trait here. I'm going to call it exception trait. And what I'm going to put here is a little bit of code. It is a static class, but it makes our life a little bit easier. And because this is an exception, we don't have a problem. So what it does is that whenever you call that statically, it will create a new self. So there you go. If you call a new, then it will create itself. So now in my invalid token configuration argument, I can do use exception trait, and then in my token validation exception, I can do use exception trait, and now these ones will have the new method. And where does that help us? It helps us here, because in the JWT token we can now capture this EX, and then we can do throw new throw token validation exception new EX get message, and that one will throw the exception. It doesn't offer a huge amount of flexibility in a sense that we're gaining so much time and performance and this and that, but it makes it just a little bit easier for our code to work. And yes, you do see me using static methods. I don't like them, but in this instance they're perfectly fine. Alright, so now that we have the object, let's go and get the actual record. So what we did up here is we have a record of a user and we want to get the token. So by calling get for user, we're going to get a token, a string token. We're just going to send it out in the wild. Somebody picks it up, wants to create a request, sends that to us. Assuming that the token is okay, it is a properly good string, we can see it, but we cannot validate it. So what we do is we send it here to the get object, and that one parses it. And if there is a problem, it will throw an exception. Otherwise, it will return the token object. And now that we have the token object, we need to figure out which user this belongs to, and this is what the get user will help us with. Okay, so for that we need to have three pieces of information: the issuer, the token ID, and the user ID. Issuer equals how did we call it? Token get claims, and now we need to do the get JWTEnum. We need the issuer value, so we need to get what the issuer is from the token. We need the token ID, and this one will change to ID, and we need the user ID, and this one will change to user ID. If you recall, the last one is a custom claim that we added, and this one will be a string, and this one will be a string. Alright, so now that we got these guys, let's create our criteria to do the database call using the query transport. So if I were to find this user in the database, I will have to match the issuer, the token ID, and the user ID, but also the status flag. If you recall, here we have a status flag. We need to make sure that this is a valid user, that this user is active. So user ID equals user ID, USR status flag equals flags enum active value. Now we need USR issuer equals the issuer, and USR token, it's actually token ID. And that's our criteria. So the query has to match all these four. Okay, so user equals, now we need to use our repository, and then user find one by, and then throw the criteria in there, and that one will be a T user record, because it could very well be empty. The record might not have been returned, or not found, rather, not matched. So there you go. Now we have our user here. So the very last thing that we need to do, now that we got the user, we can parse a token, we can find a user, and now we have to validate the token just to make sure that the token is active, is valid, correct signature, and so on and so forth. Right? So let's have a quick look here. Now we have a user transport here. Actually, let's call this user. Token object is perfectly fine, but this is our user. So what we need to do is we need to create a new validator that will validate the token based on what we have selected. And we know what we have selected because we know that we selected the HMAC and with no parameters, so that's the 512 SHA. So equals new validator, and it's the validators of the JWT, and in here we need to pass the token object. Also we need the signer equals new HMAC, and we need now equals datetime immutable. All right, with this information we're gonna try and validate everything. So the way this works is you call different methods on the validator, and once everything is done, you just once you have all the methods called, then you call the get errors from the validator, and if it's empty, you're fine. If it's not, then something's wrong. So let's see, validator, and then we're gonna have validate. Let's do the ID. So the ID will be user get token ID. Just a note, the minute we passed the token object in here, now the validator knows all the claims and all the headers of the object. Okay, so let's assume that your token object that came from the token object that came from a string that was sent. Excuse me. The token string that was sent by a request. That one contains ID 10 or something like that. Now the validator knows about this, but when you throw the user in it, you need to make sure that that user corresponds with what the token is stored with. So this has to be how it's matched. So we need to do the token. So you're matching the database user with what is stored in the token. Okay. Now let's go with validate. Let's go with the audience first. The audience will be the same because it's still gonna be this get token audience. So we're just making sure that the audience that was sent is the same as the one that we have here. And now we have validate issuer equals user get issuer. The next one will be validate not before equals now get stamp validate expiration now get timestamp. Let's do validate issue that again now timestamp. So we got all those done. Now we need to validate the signature. And the signature will need the signer, which we've discussed. It's the HMAC, and we need the password of this. This is the get token password, where it comes from, because that's the one that was used to create the payload, and we need to use it to decode the payload. And then we need to validate claim, and this one will be the JWTEnum user ID value is the same as user ID, the ID of the user. Alright, so now that we've called all these, we need to get errors equals validator get errors, and then return errors, and this one will be devalidator errors. And actually this one should also be an empty, because it might not have any errors. So now we got this class and it's all done. Let's add the tests for it, and then we're gonna move on to how to tie this thing with everything else. After this we're gonna move to the container, but let me see, do the tests require the container? They do. Okay. Right, that's our class. Let's do just a tiny bit of work on the container after this, and then we're going to tie the tests to this, because on the container part I don't only need to add this class, but I also need to add the cache. So let's do that after we add the cache, and then put the container back into play, and then add the tests. So we need a custom class, or an extended cache class for ourselves, for this application, and we need to store some information and have some additional methods that we can call in that class, just to make sure that we keep everything nice and tidy. So let's see here. We're gonna call it cache, of course, and we're gonna throw it in here in the cache folder, and of course we're not gonna need any of that. Let's not leave it final. Class cache extends cache, and it's this one, and we're gonna put an alias on this. Right, so we don't need any of that. Let me copy the contents so that you guys can see. There's no point in just typing. Said this a million times. So let me copy this and then put this one in. And we need some imports here. SHA-1 user transport. We need the dates. Datetime mutable, of course. and we need the EnvManager. Okay, that's fine. All right, so a few things that we can use here right now, and some of them will come up a little bit later. So here's some constants. So I have the lifetime day. This is in seconds, hour, minute, month, and the token expiry. I have it at 14,400. That's 4 hours, and all that. Well, we did mention here in the JWT token, there is a to-do up here that wants to find the default value. So now that we have a default value over there in the token expiration, we can just say that this one will be cache token expiry. There you go. So now we have the default token expiry from our cache would be 4 hours, unless it gets overridden by any other case. Now the mask token user, this is a mask for the key that will be stored in the cache. So TK is just a prefix, and these two placeholders are for a sprintf to inject information. And you can see it better here in the get cache token key. If I send a domain user in there and a token, well, what can you create as a key for me? And the key is gonna be the ID of the user and the SHA of the token. I will explain more on this, why and how we store the tokens this way. So that's our class here, and the stored token in cache, we're gonna need this a little bit later. Let's just simplify we're gonna need this a little bit later, so bear with me on this. We just need now this cache class to be here where we need it to, and now we have to register everything in the DI container so that we can start using all these things. For the DI container, let's go up here. Alright, we have the cache. That's perfect. We do need the JWT token. And of course, when I reorganized the code, everything went alphabetical, so I just need to take them out again and just leave the common services in one area, and then the rest of them a little bit further down. Makes it a little bit easier to see. So the user get service goes under here. The repository is, I guess, where it's supposed to be. Yes. Alright, so it's a little bit better this way. Now for the services, we have the cache one, the cache constant. Let's create one more constant called JWT token, and we're gonna put it here. Oops, wrong. Right. And actually, because this is a simple class, it doesn't really need to be in the definitions. It will automatically create it. We can adjust this a little bit later as we move along. If we need this to be, let's say, a shared class, we can certainly do it, put a definition further down for this. Now, the one thing that we do have to do is the cache. The definition for the cache. Alright. And we're gonna copy the connection part and we're gonna adjust it, of course, because they're kind of similar in a sense that we have certain options that are required, and then the cache component is being created. There we go. So what do we need from this? We need an adapter name and the options, and in our case we have Redis, so we're going to construct our options accordingly. Let me get rid of all of these, and using this we're gonna create first of all we need the prefix. It's the prefix for our cache. Manager get cache prefix, and let's put dash rest like that as one of them. Then we need the host, and then we need the lifetime. Let's put actually cache like that, and then we need the index and the port. And the cache index will be 0. Port is that. Alright, so this one is a string. This one is an int. And I'm pretty sure we need to cast it as well. We need to cast the index, and then we need to cast the port. Alright, so now that we have all that, we need to create an options array. And in here we're gonna have host equals host, index equals index, lifetime, prefix, port, and unique ID. Unique ID will be our prefix as well. Just leave it prefix, that's fine. And now finally we need to find what the adapter is. Manager cache adapter, and that will be Redis, and that's a string. Alright, so to create the cache we need to go backwards a little bit, so from start from the back and go to the front. So we need to figure out what kind of serialization we're gonna have. And that serialization, you can set it up with the settings and the options that you have. We're just going to leave everything default. So we need serialization, serializer factory equals new serializer factory, and that's a storage object. Then we need the adapter factory for the cache. There you go, and that one requires this serializer factory in there. And now what we need is we need to get the adapter itself, and to do so we need to call adapter factory, and then on it call new instance, and then we need the adapter and then the options. And now with this, finally return new cache and the cache adapter. like this. We can shorten it a little bit. We can wrap everything in one go here. We can just leave it as is. I think it makes it a little bit easier for newer developers to visualize this. Alright, so now that we got the cache and we got the JWT token, we have to move to a couple more things before we touch the EnvManager. I want to prepare the HttpEnum and also add a better password mechanism for the tests. We can do that, and then refactor EnvManager, add the login action, and then do the middleware. And while we're doing that, you're going to see how all the JWT reacts into that. I need to copy a couple of tests here. We said that we're going to do the JWT tests. Might as well do the not this one, the cache test as well, because we certainly want to test that that particular component. So what we're going to do is we're going to go to providers and copy this, and we're going to call it cache data provider test. And what I'm going to do is just going to copy it. Okay, so what we need is the cache here. Actually, it's very simple. Container get container cache, and then this is the actual expected equals class, and we need this as assert instance expected actual. A bit of an overkill here. We kind of know that this is gonna be what the cache will return. It will return a cache class. That's how we registered it. Again, it's all about what happens if you make a mistake and you make a change that would pretty much destroy your whole application without you even realizing it. What if this cache class is no longer this class, it's a different one, it's the Phalcon one? Because if it's the Phalcon one, yes, it will work, but it won't have all the constants in it or the other methods that will break your application. So let's just leave that there for now. Let's create a token class here. I will test our tokens. Token test. Alright, and I'm not going to bore you with all this stuff. What I'm going to do is I'm going to copy and paste the whole testing methods, and I have one that I need to get rid of here because we don't really need this about the unsupported claims. Alright, so let's put some references in. User repository, query repository, user repository. I'll explain these ones in just a moment. Oh, I forgot the user repository needs to become okay. Token, this one, and there you go. All right, so Very quickly on this test, I'm just keeping the JWTToken service here just so I can use it. So what we're doing is get for user returns token string. So I have a user, I send it here. I just make sure that I get a proper string, that it's not empty. If I do a get object, do I get an actual token class back? Yes, I do. Now, granted, the get object will always return a token class because that's in the signature. It cannot return anything else. But if there's an error that it cannot return or it cannot decode this token, this test will fail. Right? On this one, object throws on cannot decode. Get object throws error on cannot decode content on invalid token structure. And this one here, let me just shrink it for just a moment, is another error. The success here is, there we go. The success here is if we get a proper user, and then we get a proper object, and then we validate everything, and then we don't have any exceptions. This validate, actually we need to change it here. Errors equals this validate, this assert, empty. So if the validate does not return any errors, it's fine. Now for this one, get user returns user array, we want to mock this and we want to not interact with the database. So here's how we're going to do it. We're getting a bunch of user data, right? And the user data is here. It's some data here, a user ID, a token, an issuer, and a password. Okay. So we got all that. Then we want to get a token string based on that data. So we get our token. And then this plain token, I could have used token here, but it's okay. This plain token is the token object, right? So now what we need to do is we need to make sure that when we're gonna call the get user, meaning I have my token object here and I need the repository, the query repository, and I need to call that so that I can see if I can get the same user from the database. But I don't want to access the database. I could, but I don't want to right now. So what I'm doing is I'm mocking the user repository so that when it calls find one by, it will return this guy here. And then in order to mock this repository, in order to mock the query repository, I have to, sorry, if I mock this user repository to return user whenever a find one by is called, that's perfectly fine. But I also need to mock the query repository so that whenever user is called in this, it will return the one above. So you're kind of like doing things, you're mocking the mocks. Now, since this is a final class, I can just take the final out and it will work. I'm not 100% sure if I want to take that. Maybe I'll have to change the test, but for now it's fine. So let's see. Composer test unit coverage HTML. Okay. Test validate success. Where are we? Well, validate returns errors, right? Fail asserting that an array is empty. Assert the same. this with actual. Let's have a look. Maybe we missed something. The token cannot be used yet, not before and the future. Okay, so we made a mistake in the token when it can be used. Easily fixable. This is a timing issue. So what happens is everything happens in exactly the same second, or there's a little mismatch. So this object gets created and there's not enough time passed for this to validate it. That's why it says it's not before and it's not after. So if we do a small trick here, sleep, let's say for 1 second, and we run it, you're gonna see that it does pass. There you go. So that's our little message here, our little hack here that we can do. Because this one will run later when you receive the token. You're not going to create a token and send it to be validated on the spot. So that's why this thing is done. Now, what we need to do is, now that we have these tests, we need to make a small change in the AbstractUnitTestCase in order to help us. This getStrongPassword is not strong enough. I've run this before in the testing suite, and I have seen that it does complain that the passphrase is too weak. If you look at the actual class, the way it's done in Phalcon, it expects you to have a combination of uppercase, lowercase, letters, numbers, as well as special characters. And sometimes those special characters are not 100% there. So what we're going to do is we're going to modify the getStrongPassword, and we're also going to enhance this class to get us a little bit more information, a little bit more utility in terms of the tokens. So for the password class, what we're going to do is we're going to keep this as is. So let's say password equals this one, the base 64 encode random bytes. Let's make this 128. And then what we're going to do is, let me copy it. We're going to have the special characters themselves. These are special characters that we can use. And now we have password array equals str split password, special array equals str split special, result equals array merge, these two, shuffle, and then password equals implode that, and then return the subs of this, and we're going to need 128 characters. So a small change, what we're doing is we're getting a password here, random characters, and then we have some special characters here. We're converting those to an array, we're merging them, and then we're shuffling them. We bring them back into a string, and then we're getting the first 128 characters out of it. Certainly plenty of other ways to do this. This is just one of the ways. Let me put the setup at the top. I do like everything to be alphabetical, but the setup is the first thing that gets run into this test, so might as well have it at the top. Now, one other thing that I want to do is I want to create this method, which we're going to use later on. It's called getUserToken, and we're going to put it, where is it? It's somewhere here. Get new user data, get from database. should be here, I think. Alright, let's bring this import here. HMAC. Oops, that's not the builder that I wanted. It's not the DI service builder, it's the JWT builder. It's this one. Alright, so what this method will do for us, we haven't used it yet, but it's coming. We're going to throw a user in here, a database user, and based on the data that we have here, it's going to generate a token, right? And that token will be used to make a request to a service whatsoever. So for instance, if we want to get the user service, the get an ID, let's say give me user number 5. In order for me to get that, I need to have a token. That's how that's where this this video is moving to, or towards. So we're going to need a way for our test to generate a token and send it to the application, and then the application will just pass through whatever it needs to pass. The token has to be valid, and then perform the actual action. So let's leave this here, but we are going to come back in a little while on this, just to make sure that everything is nice and tidy. The very last thing is I want to add a few more enumeration options for the HTTP codes enum. And what I'm going to do is I'm just going to copy it and paste it, and same thing with the test. And I'll explain exactly what these are. As you can see, we have quite a few of them, but not that many. But I want more variety. So I'm going to paste everything. So now you see we have a hell of a lot more. So we have malformed payload, records not found, cannot connect to the database, incorrect credentials, cannot update database, invalid token, user, tenant, structure, and so on and so forth. And let me just make sure that the test is fine too. Where do I have it? I'm not going to bore you with this whole thing. Where's the test? Enums, HTTP codes enum. There you go. So now we have 26 options here. And if I run the test again, yeah, it looks good. Composer analyze. Okay. Cache. So one error here. EnvManager. Oh, that's not correct there. And that's not correct there. It's leave that EnvManager over there. We're going to tackle this in a little while when we make it non-static. And in the JWTToken it says 124 is what? It's actually user, not user transport. We did make that change, and now we have no errors. Perfect. The EnvManager has many advantages the way we've set it up, but it also has quite a few disadvantages, and they're showing right now. If I run everything in process isolation, all the tests, then that pretty much picks up this object and it creates it in its own process. But if I run the test without process isolation, this object is already created at some point in a test before this test that it's running right now. And as such, this is loaded, is already set, so it will never read the files, the .env file again. And we did this because we don't want it to be reading .env files every single time we do a get. We might have 2, 3, 4 gets in one method. Look at what's going on in the container. For instance, here we have what 5 different gets here. We cannot afford to have the adapter reading the .env 5 times, right? So what we're gonna do is we're gonna change this to be a non-static class, and that will introduce its own problems, but it would allow us to control exactly when this class gets created and when it's being executed. So now here's the drawback of that. On a static implementation, this thing actually works really well because I can just call it from wherever I want to. On a non-static implementation, I need to inject it whatever I need it to. So I'm going to utilize the container for this in order to create this manager class, and then change this from a static to a non-static. It's entirely up to you if you want to do this. This is the way I do it, and the reason being is let me just run the tests here for a second, and I'll show you exactly what I mean. So if I run the tests, everything works fine. Everything passes. If I do in the PHP unit, if I remove the process isolation, meaning that each test doesn't run in its own process, and I run the tests, you're going to see I have failures. And this comes from the EnvManager because it says that null is not identical to sample value. So what happened here is the actual manager was instantiated before this test, and the is loaded is not true, so it will never hit the .env file again. It will not read it again, so it won't be able to pass this test. So in order to not have headaches, I'd very much like to get this thing working without it. Also, we have another error here. The test dispatch has an issue, so we gotta figure that out too. Process isolation is perfect, but you have to be careful because it might hide errors that could potentially fill your logs later on. It would be difficult to find. So it's good to run it with and without it. I'm going to try and keep our tests here without process isolation. So in order to get things going, okay. So let's have a look how we're gonna do this. What I'm gonna do is the EnvManager. I'm gonna extend the collection class, which comes from support. And the reason being is that I wanted to handle the collection of the array of data, if you like. So I'm not going to need these loaded, and I'm not going to need the settings. All I'm going to need is a public function construct, and then I want to call the parent, and then this load. Alright, so we need to remove all the public static and replace them with just public. Alright, so now they became public classes, public methods. For this one, we're going to need this get, and we're going to get rid of the load. Again, same thing. Let me just copy this part here. And actually what we could do here is put comma and put int there, and it will work in a minute. We don't need this get. The get exists in the collection. So if I come up here now, it does have this third parameter called cast. It's going to be an integer, so this is an integer and I don't need to cast it anymore. The get automatically casts it. Path is fine. Time zone needs this, and I can do just leave the string as is. This one needs this here, app path, and private function. And in this one, we're gonna have to make it public and not static. We don't need the is loaded. All we need is this part. And for settings, then all we have to do is call init. Actually, we're gonna do this clear, and then this init settings. So what we're doing here is we're utilizing the collection object that exists in the support namespace of Phalcon. And when we call load, which is called, if you noticed, in the constructor, so whenever we call this object, when we call load, it creates the env factory, grabs the everything, calls .env, blah blah blah, and then it clears the internal collection. Of course, during construction it's gonna clear nothing because everything is empty, but then it initializes the array, the internal array, with whatever settings we have. So this one will be populated with all the necessary .env settings and variables. If later on we want to reload this because something changed in our environment, we can call load again and it will clear it and initialize again, and then it will read it again. So that's how this one would work. And we could even take this part, the get options, and put it into the load, but it's fine the way it is. Let's sort it again. There you go. It sorted everything just fine. Okay, so now that we have this, the very first thing that we need to do is we need to put it in the container. So we're going to come here and call env. Env, and here we're gonna have env equals this. Now certainly we could have used the config object to do this work. It's up to you. I just created a different class. It doesn't really matter that much which option you use. Let's go to this guy and clone it. And what we're going to do is get service env, return new EnvManager. That's all we need to return, and we need to have it shared. Okay. Now also in the container you see we have references to this, right? So what we're going to do now is we're going to say env equals this get shared self env, and that is an env manager. And let's copy this for good measure. And now this one will be env get. Just replace all these. This. I'm gonna fix those in a minute. Let's go back to the cache. So we got our EnvManager from the container. We're doing a get here. We're doing a get here. These ones we don't need to cast them here. What we can do is cast them here, and then instruct PHP stand that these are actually integers, because this is a feature that the collection has. In the last parameter, you can just say, hey, cast this to, and if you put int, it will cast it into an integer. That is done. In this case, in the get service connection, we just need to put this EnvManager. That's perfectly fine. We're going to do the same thing here with a port that we just did. We're going to remove the int and then put it here so that it gets it, it casts it properly. And then we have these guys over here. We're just going to paste the EnvManager. Actually take them and put them inside the closure. Of course, we don't need the use anymore here. And this looks fine. So I do expect errors, of course, because we just made a huge change. But we're going to be able to figure them out very quickly. It's not going to be a big problem. Alright, so we have JWTToken needs something. Let's have a quick look. It has it certainly down here. Yeah, okay. So in order, this is what I was talking about, the disadvantages. In order for me to use the EnvManager here, if I had it statically, it would just use it. But if I don't, I have to inject it. So I need to come up here and create a new public public function construct, and then private read-only EnvManager env, and nothing to run on that. So this one will be this env get, and then in here it will be int a cast, and we don't have anything here, we only have it down here. And again, this env get, and that makes us to go back to the container and go up here. Now this is not going to be a JWTToken, it's going to be a JWTToken like that, and down here GHG. Okay, so it's below this. We're going to have JWTToken, this get service token. Let's copy that. Let's go back here and let's clone this. That. And now the JWTToken will require the EnvManager. So let me grab this definition here. Saves me from typing. I'm going to use this syntax. Here I'm going to need the env, and this one will be the JWTToken. So my token class now will have the env service injected into it. Alright, let's run again. We had 20 errors before, now we have 16. Let's have a quick look. Where does it blow up? .env test, app path cannot be called. Okay, tests. It's primarily the tests that are failing, not necessarily our code. One more thing I need to do here, which I discovered kind of like by accident. I need to change this here to create mutable, because when I'm running the tests and everything is loading and so on and so forth, there is a time where in the environment I have something set up, let's say AppEnv, and I have the same thing set up in the .env file. And if it is immutable, that means that my setting reading from the .env file will not override what's going on in the $_env superglobal. So I want it to be overridden right now. Of course, you can change this to whenever you want, but for now we'll just leave it like this. So let's go to our tests here. All right, we have a setup here. What we can do is parent setup. This will create our container. Env equals this container get container env, and this one is an EnvManager. Let me copy this and keep it, and then this one will be env app path. All right, let's have a quick look. Nothing here. In the EnvManager, we're going to have a lot of them. So this setup doesn't require all that. We're going to leave that. We're going to copy this guy here. And we're going to change all these references to env. Like that. Okay. And let's have a look. Alright, so we need to put this here, and actually we could do get shared. It wouldn't hurt. When this test runs up until this point, you just have the container. Because everything is lazy loaded, the env has not been invoked yet. So I'm manipulating the env environment here, the superglobal, and then I'm loading this. If I had this above this line, this thing would not work. I would have to call the env load to reload everything from the environment. So that's why I'm putting it right below that superglobal. Again, same thing here. Here. Same thing here. Let me just close this. And here, I need to put it down there. All right. So what I'm going to do is I'm going to leave it as is, because I don't want to be creating different variables. I'm going to leave it there. That will work. And now what I'm going to do is, because the env is here, this superglobal, and I want it to be, I want it to load, I'm going to have to call the load again. So now, upon creation, it loaded the environment from the .env file, but now I wanted to load it from a different point, so that should run it. So let's see what we've done. All right. Excellent. Now error handled provider. All right, we have quite a bit of the EnvManager here. We need to go to the main class, really. Where is it? Here. Because we do have stuff here. All right, so logger equals that. Let's copy this a couple of times, and this one will become EnvManager, will be env, and the method, the variable here is called env, and we need to get the logger env, and also we need to get the time from here. Alright, now that we have all these, and you will see where the time plays into this. This is what we need to do. Alright, now here on the shutdown, we're passing the container. And I didn't notice this. This was a big boo-boo on my part. You should really never ever send the whole container into one class as an injection. You should always bring it's an anti-pattern. That's what the books are telling us and all that stuff, and it has huge disadvantages when you do that. Instead of just injecting exactly what you want, because you can control 100% what this method is doing, versus this method getting the container by reference and potentially changing components in here. So what we're going to do here is we need three things. We need the EnvManager, we need the logger, and we need the time. Okay, so let's make sure that we inject them properly here. So first and foremost, we're gonna put the logger, EnvManager, and int time. Alright, so if I get rid of these two, that's fine, and the only thing that remains is the EnvManager. Block level, perfect. So this on shutdown became a method that accepts only three parameters, and we need to change the on shutdown function the second well, the parameter after the second will have to be first the logger, the env, and then the time. And that's what's gonna make this thing work, and it's better to have these services properly done. Let me just come back to the tests now, because the tests are the one that are gonna complain the most. Up here, let me quickly go to this one and copy this line, because we're gonna need it. Alright, so in the error handler provider we have the time here, which is being set, and what we need also is the EnvManager. Let's put it down there, and let's make this change here, the replace. Let's replace everything, and let's check everything. So this one will check the env time zone. Perfect. Let's go here. We need the env down here. There you go. We need the env up here, so we have it, and we need to take this thing and put it at the top. We need to make sure that the time is there. Now the error handler provider should be fine. Now these two, whenever they run, they will go to the error handler provider and they will ask for the env, right? So what I need to do is I need to take these guys and put them before, put them up there. So that should work. Should. Three. Alright, so the register shutdown is not correct, and of course it's not. because this method invoke has the provider, but it doesn't provide the proper stuff. So we need EnvManager. Let's get the logger here. Because in this test we're invoking that shutdown method. Here we're making it accessible with reflection, and then we're invoking it. So this one will require the logger, the EnvManager, and the time. Now the time is up here. We could have skipped this, it's fine. So now we should have less than 3 errors. We have 2. Yay! So the 2 errors that we have are dispatch errors, and they are in the services. So here in the hello service, what I'm going to do is I'm going to paste this, and then I need env path, and on this one again I'm going to paste this here, and I'm going to do $env path, and now running the tests. It gives me this error here, the test dispatch user service. This is kind of like a hidden error somewhere that I haven't been able to find out yet, but we will do so. But for now, our refactoring of the EnvManager is complete, and we can move on to other stuff. We're gonna move forward with removing the hello world, and this has been something that we created initially so that we see that we get a response from our API. It hits the root, so we don't really need it anymore since we're going to create a brand new endpoint for the login. So simply just delete here the test, and delete the hello here, go to the container and figure out this reference here and this one here. Additionally, we need to go to the routes. We need to remove hello get here, and the hello service, and everything else is done. But I know that my tests are gonna fail because I don't have this route anymore, and in the router provider I don't have the get here. So if I run my tests, I have one error. Routes enum check count. Where is it? This one. It should be 1 here. And that should be fine. Now, one thing I just want to quickly mention here, when I was talking about the EnvManager and the process isolation, I had to turn process isolation to true, because if I have it to false and I run all my tests, everything runs apart from when I'm dispatching the user here, this user test. Now it works, but it doesn't work when I had the hello service. I don't know what was going on. One test was interfering with another, but I was getting this, where is it? this message here, the user service test dispatch was just returning null. So I'm guessing it was interfering with HelloService or whatever. Again, another pointer, keep the process isolation off and on depending on your tests. It's better if it's off in order to make sure that everything is working fine, but also put it as on, meaning that every test should run on its own space, and that would allow you to have different results. So the next thing we have to do is to actually add a new service, a new endpoint. So this endpoint is gonna be a login endpoint. So we're gonna call it auth login post. We're utilizing the name to give us an idea of what this would be, and this one will be auth. Now let's make this auth login. Now we can change this a little bit later, and we are going to change it once we introduce the auth refresh. And you're going to see different changes here in the enumeration, how we're going to be able to have kind of like a root object. This could be the prefix and then different suffixes, and how that would affect the routes, and why we use the collection in order to work with the routes. But for now, we can just leave it to auth login. So for the auth login, it's gonna be a post. We don't have to touch the middleware. For the service, let's leave it to the user get service for now until I create the actual class. And of course, the router provider test, now we need to change this to a post, and then auth login, and the routes in num will be, it will be auth login post, it will be auth login. I'm not sure if that's correct. What's the second one? Is the, oh, it's the value. Okay, so that should be correct. And we're going to change this one too. Okay, so to create the new service, we have the routes, but what we're going to do is we're going to copy this service to be called auth, the folder rather. And the actual service, we're going to call it as login post service. It's this one here. Dang it. This is the test. Let's remove the test for now. Let's go to the main. Let's give us some space here. This one will become auth. And this one here now will become login post service, and then this one would remain to login post service. Okay, and what we're gonna do here is we don't really need these ones. What we're gonna do is we're gonna send a payload of success, and then let's say data will be okay. Alright, and this one will have to be auth. Okay, that's fine. So I need to send something. HTTP client. What is my IP? REST API 8.2. The IP is 6. one. Copy. Actually, let me go to the post examples. I'll copy that in a minute. Leave that like that. Application JSON. So if I run this, I should have resource not found. Great. And for this, let's just copy this part. This is the post. And what we're going to do is we're going to do email equals 1@2.com and password equals secret. This will be password. Doesn't matter what we send. I just want to make sure that this thing works. So if I send the request, it says resource not found. Of course. Auth login. Again, resource not found. Alright, let's check our routes again. So providers and enums. Auth login post. Alright, goes to user get service. This one will have to change. So come over here. We have how should we call this? Auth login post service, yes. Okay. And then for services we need to, let's just put that there, leave the repository above it. And the name of the method will be getService auth login post. Let's copy it. Let's go down here and let's clone this. Login post service, and this one should be at the top-ish because it starts with A. Right here. Alright, so in the routes enum we have auth login post service. Where's my test? Because it's gonna fail, I know. This one will be auth login service. Container, router provider, JWTToken. It's fine. So if I send this, just to make sure, it's 1806. Let's make a quick check here. Database is not correct. Let me just find the database again. The IP is 03. It's not 2, 3. And I refresh here and I open the users. There is 96 in here. Okay, so if I go back to my code and I do 96, I should get something. Alright, so this one executes. Gives me this guy, Joshua, Carly, Con, whatever. If I do it like here, pre-print, it gives me all the data. And this is a user that was left over by the tests, so it's fine. So now this one says 5. Docker p. Oops. Docker ps. We need REST IP 2. That says 6. I'm guessing this is a different container, but if I do 6 here, it gives me exactly the same thing. Alright, so 6 works. 172.18.06. So if I get the same query on a get, it should work. Ugh, dang it, I just said it. I have get here. That's why it wasn't working. There you go. I got data okay. Alright, problem solved. So this is the post service. I just returned an okay here. So that is pretty much working the whole route. So what do we need to do here? We need to receive an email and a password. And then what we're going to do, let's write it down actually. That should be a good thing. Get email and password from the input. The next thing we're going to do is sanitize and check if email or password are empty. Get then what we're going to do is we're going to say find the user in the database. Then we're going to have check if the user exists and if the password matches. Then get a new token for this user. Store the token in cache, and then send the payload. Oops. Send the payload back. Alright, so that's what we have to do. Alright, for starters, we need to check the email and password as they came in, and those will be in the input array. Okay, so email equals, we're gonna cast a string on the input email or empty. So what we're doing here, if the email was not supplied, then return empty and then cast that into a string, which will be a string. But if email was sent and it was sent something else, just cast it as a string either way. Do the same thing with the password. And this one will be password. Now let's use the filter. Email and password, the same thing with password. So we got some sanitizing over there. Now what we need to do is we need to check if the email or password are empty. If true, empty email or true empty password, then we need something here. So what we're going to do is we're going to say return this get unauthorized payload, and down here we're going to have a private function get unauthorized payload, return your payload, and this new payload will be domain status unauthorized, and the results in this would be errors, which will be an array of HttpEnum, incorrect credentials error. Close this here. So the get unauthorized payload will actually send incorrect credentials to whoever calls it. Okay. Now we need to find the user in the database, right? And good thing we have the query repository here. We're gonna say dbuser equals this repository find user, and now on this one find by email. We need to make sure that we have the user ID. Let's make that an int. User ID or 0. Great. Let's do the same thing with the password. Alright, so we got all this information for us. We could certainly check if the user is empty and throw the exception here, or we can do two checks at the same time. So if db user ID less than 1, or so if it's 0, true not equals this security. We don't have security here. Was it validate verify, I think? Password and db password, and then that one will throw new get authorized. Alright, so we're missing the security component here, so let's add it. Let's put it at the bottom here. And of course in the container, this is the auth post. We need security here. Alright, so now we have the security component with verify-work. Perfect. Now what we need to do is we need to get a new user, get a new token for this user, and of course we need the JWT class. Right, so that is there. Of course, container, it goes above the filter. Alright, now we have the JWT class. What we need to do is we need to say token equals this JWTToken get for user, db user. Let's get the refresh token as well. We'll explain that in a minute. Actually, no, we can just leave it. Leave the refresh. We'll do it next time around. So now we need to get the user transport so that we can have this user presented in the domain, and then create a new payload from the transport to put everything where it needs to be. So what we're going to do is say domain user equals this transport new user from the DB user, and we also need to create this payload that will come up here, and we can utilize the transport here, this one, transport repository, to create this payload the way we want to. All right, so first of all, let's go to the user types and figure out what this response payload would be. All right, so PHP stand type, let's call this login response payload. That will be an array of. All right, so let's have authenticated, true. Then we can have user, which will be an array of. ID will be int. Sorry. All right, ID int, and then it will be name string, and then we're gonna have email string. And also below that, we're gonna have a new node called JWT, which will be an array of token will be string. Underneath here, we're gonna put the refresh token as well, so at a later stage. So that one is that. Now in the transfer repository, let's bring this in. Okay, and let's create this. So let's call this new login user. And this one will return an array, and the array will be login response payload. But what we're gonna send to the user, first of all, we're gonna send a user transport, and the token, and this one will return authenticated equals true. User will be ID, user get ID. Name will be user get full name, and email will be user get email. Right? So that's how we're creating this payload, and that one is done. And now we need JWT will be also an array that will have token equals token. Alright, so that's my new user. Don't forget, this one needs to go down here. Later on we'll inject the refresh token as well here, and we'll put it there as we mentioned before. So back to my login, what I need to do is I need to create this particular payload. So I'm going to use the transport again. This transport new login user now, and we're going to need the domain user and the token. And now that we have that, we need to store this item in the cache and then send the payload back. So return new payload, domain status success, and this one will be data equals results. And how we store it in the cache is interesting because we don't have the cache service here. I need to close this. So let's add the cache service here as well, and I'll explain what that means, what that entails. So private cache, again to the back to the container. It's right below here. Now back here, we need to utilize the cache to store the token. This cache, store token in cache. It needs the env. Alright, so let's say this env, and then what's the next thing that it needs? User, transport, and token. So domain user, and then token. We just need this env. This is what I was saying before with regards to the actual injections. Yes, the EnvManager, if it's a static class, you don't have to inject this, but since it's not, you have to. Unless what you could do is in the creation of the cache, you can inject the service there, but that's not always the case. You cannot just arbitrarily start injecting things. So for this, we're just going to have to put one more thing below the cache, which will be the EnvManager. EnvManager, and that's env. And now this one is fine, but we definitely need the container to be changed, and this one will be env. At least with this declaration here, we can inject as many components as we want in the constructor, and it's literally 2-minute change, so, or 2-second change or whatever. So this is what we have now in this class. So what would happen if we actually send a request now? What are we going to get? So auth login, whatever, and send it. We get incorrect credentials, which is great, right? Let's have a look at something here. We need to do a little bit of hack here in the PHP. So what we're going to do is we need to create a password using our password hashing mechanism that we know about, because the users that are entered in the database are all randomly generated passwords. So what we're going to do is php -r var dump password hash of the word secret, and then password argon to I. That's our algorithm, and that one will close there, that one will close there, this and this and this. Alright, so this is our password. This is what comes down as secret. Let me just copy this. I'm missing the last O. There we go. So let's copy this, open the database. We have one user here, major colons, and delete this, paste this, save it. And now I need to copy this and go back to my HTTP, paste it, and let's see what happens. So we know secret is okay, callings this is that. We get incorrect credentials. So what's going on here? very quickly, let's have a look at what we get as a return from this. So in our debugging, what I'm going to do is I'm going to copy this guy, and I'm going to paste it here. And what I'm going to do is I'm going to put, for errors, just put input here. So what this will do is if there's something wrong up here in this step, this one will return the whole input array. And of course I could have done this with tests, but let's see, let's make it more, a little bit more visible, because I'm not 100% sure on that. Alright, let's go back to the REST API, send it. You see errors input. The input is empty. So we're not getting any data from the top layers of this. Alright, so if you recall, the action handler is the one that handles everything. So if we go here in the action handler, it just does everything here. Well, it utilizes this input class, and that is the one that collects all the inputs. So let's have a look, and lo and behold, here's our problem. We are now doing a post, and that data is not returned back to be injected into our domain interface. So what we need to do is we need to clone this, make this one post, and make this one post, and the request will be get post. Oops. And now what we will return will be array merge query post. So now if I go back here and I send this, I get incorrect credentials again. Collins major camarada.org. So the question is, did we send the data correctly? So let me just revert back to this just to make sure that the input is being sent properly. Alright, so the input email and password is properly defined. So email password here. Email password is here. Let's see. Email on the first and input on the last. Let's send it again. So he has this, he has that, and he has everything. So far so good. This one, it's operator error. If it's empty, or if it's empty, if the password is empty, then do that. It's not true and false. Alright, so we just sent this, and it gives me an error, right? So auth login post service cache store token in cache. Okay, that comes from this component here, and yes, we do have a problem here. So env, and we need to do env get, and that will be int. So that should work, because the call was not correct. So if I run this again, aha, there's the authentication, Joshua Carley, whatever, and there's my token. And if you recall, I told you that it has the dots. So that's great. We got this working. And next we're gonna do the tests. Let's create this folder here under unit domain services user, and we're going to call it auth. And this test here is going to be called LoginPostService. And of course this one is auth. And we're going to rename this. Okay. So what I'm going to do is I'm going to copy the tests as I have them, and I'm going to explain what is going on. So one of the tests we need to do is have empty credentials. This one is service enum. So if I run the test now, writer provider, these are all my mistakes. So router provider test is, what does it say? Failed asserting that two strings are identical. Post login. Is it user login or auth login? Enum's HTTP routes enum test. It's auth login here. Check count should be 2. I complaints about that one. Probably it's the order. It's not this. It's this one. I think it's the order. It's how they're being defined, because one is above the other. We'll address that in the future. So yeah, that's the one. Alright, so it generated some data for us. So if I refresh here, you see I have certain things that are not working fully. This is our post service. It came up here, it checked the input, and then it ended up here. So that's great, because we created a test that has empty credentials, right? So we need to create a test now that has proper credentials, and we have to make sure that it does work the way it should. So let's create one that says wrong credentials, right? So let me copy this from the other side. We don't need you or you or you or you. Let's close these guys. Let's put this one here. So what we're gonna do, why did I have this thing here? Oh, whatever. Alright, so we're picking up the login post service. We're creating a new migration. We're grabbing a new user here. And what we're going to do is we're going to send a password with the wrong, we're going to send a user and a password, but the password will be wrong. So when we hit this, we should get unauthorized. There we go. If we go back to our browser, if we refresh, now these lines have executed. So it did find the user. It went over here,
and the password didn't verify or the user was not correct. Okay. We could create one more test, and I will a little bit after this, that will handle the DB user ID. So now we have to go on this part, and that one is a little bit more elaborate as far as a test is concerned. Let me just copy it over, and we're gonna have to make a couple of changes because we don't have the refresh token yet, but it's gonna be done relatively soon. So we get that, we get the password, we're sending the password, invoke success. All right, so we're getting the post service, we're creating a new migration, and we're setting up a password the way we want it, right? It is a password of sorts, we can change that, and then we're sending this there, and then the service invoke, it hits the payload, then it should say success, and then we should have data, and then the data should have authenticated user and JWT as top nodes, and then the authenticated should be true. The user node should have a user ID and a user email that match our database. And then let me just close those because we don't have the refresh token. And then check the token and make sure that it does exist. So all the tests passed, so if I refresh here, it actually went through. So this code actually works, and it generates tokens for us so long as we pass the proper username and password, which is fantastic. Now all this work that we've done is great, but what we need to do is we need to make sure that the token is correct, right? It's great that we can get a token, but what are we going to do with it? Well, what we're going to do is we're going to protect the rest of our application other than the login with middleware. So the very first thing that we remember, we have the login post service and the user service. So we have to protect the user one. So anything other than login post service. So what we do is we need to make sure that all of these things, all of these endpoints are protected by the token, and they're not the execution stops as early as possible. So we're going to take care of that by using middleware. So what we're going to do is we're going to copy this, and then we're going to call it validate token validate token presence middleware. All right. And of course, I copied the test again. Sorry. Let me shrink the tests and go back to my middleware up here. This one is the one that I need to copy. So validate token presence. The very first thing that we need to do is just to figure out whether the token exists or not. If it doesn't exist, there's no point. We can just send them back where they came from. Okay. Now, here we need to get the request, and we have to find the actual token from the headers. So let me go first to the abstract middleware, and what I'm going to do is I'm going to create a couple of helper methods that would allow me to check this. So public get bearer token from header, and that's a function. Request interface request, and then EnvManager env. You will see why in a small amount of time. And then string, and then this one will say, okay, let me copy it and I'll show you why I'm doing this. All right, paste. Okay, so there have been environments, especially local ones, that the authorization header is not read. I really do not know the conditions on how to do that, but I have experienced this, and my get around was to make this little method here, which will allow you to get a different header that you would define in your env file. So if I define API header auth will be, Susan, whatever, and in my request I send Susan as a header, then it will read that. Otherwise, it will read what says authorization. Okay, so this is why we're doing this. And then, of course, we need to use one more. It will be a public function is empty bearer token, and that one will need request interface EnvManager, and that one will return bool, and it will be return true, empty, this, and that. All right, so these two methods are going to help us checking the tokens and all that. Okay, so in the presence one, in the presence middleware, we don't really need to check the health, right? Because this middleware is going to be after the health one has executed. Okay, so we don't need to check the not found and all that stuff. So the health is irrelevant. What we need here is also the env, of course, because we're going to need it in the check. EnvManager. And in this case, let me just get rid of that, leave the halt for now. What we're going to do is we're going to say if true, this is empty bearer token request and env. If it's empty, then what you're going to do is you're going to send a halt, and that will be the application. The code will be unauthorized. Actually, should be, yeah, we can put app unauthorized as well. It's entirely up to you. Unauthorized, and then the payload will be nothing for the data, but for the errors will be HTTP codes enum app token not present, and then error. Alright, so what are we doing here? That's fine. We're grabbing the request and the env. We're checking with this method if the bearer token exists or if it's empty. And if it is, then we're halting the application with an unauthorized. Okay? So let's put that into perspective. What we need to do first is we need to go to the enums HTTP routes enum, and now we have a middleware that we need to put up here. Okay, so middleware, how are we going to call it? Validation, I guess. Let me just copy it. Give me a sec. It will come in the container. So under middleware, let me copy these guys. Okay, and let's organize this a little bit. All right, so we want the presence one. So I'm gonna comment the other ones. That gives you an idea of what's coming down the line. So validate token presence middleware. Let's import this class. All right, so that's my class, and this guy needs to go in the routes enum, and it will have to be after health. So the first one to be checked after the health. All right, so now if I run my testing suite, I get invalid token not present when I'm trying to do a user service test dispatch. So what we've done is we've protected this one here, the user get service. Let's add a couple of tests for this, and this time it will be in the tests folder. Domain services. Let's leave this up, and then let's go to middleware, and this one will be validate token presence middleware. Okay, let's copy this. Validate token presence middleware test. Let me just grab this whole thing and just paste it here, and I'll explain. Okay, so in order to test this middleware here, I'm going to pick it up from my container. I need the micro because I'm testing middleware. I'm going to play around with the server array. For now, I'm not worried about this. All I'm worried is if I don't have a token, will I get something? Will I get an app token not present? And this is my payload. What am I checking? Now, if I do have a token, and let's say I'm getting user ID equals, I just made a mistake there. Those don't matter that much. If I do have a token, that means that the middleware will not return false. It would keep on going, right? So for this part here, I'm just checking, all right, this is my payload, this is the server. Let me call it, and if I call it, because the token is not there, it's going to return false. Reminder, whenever you get a halt, you get a return false. Or do I need to? Let me quickly check. Yes, I do need to. I need to put return false. Apologies for that. Just checking notes as well. Alright, so if the token doesn't exist, so the authorization header doesn't exist, then it will return a false. But if it does exist, it will return true. So now if I run this, it should still have one error, which is fine. But looking at our code coverage, if I go to domain components middleware and this one, token presence, you're going to see that it has executed this part, and then executed this part too, this one here, because the token was not present. So this middleware, the only thing that it does is it checks if there is a token. It doesn't check whether the token is valid or not. We're going to check that later. And this follows our remember our onion architecture. So you catch an error early and you stop the application as early as possible. So if somebody sends a payload and doesn't have a token, just stop it here. So anything after this will never execute, and that saves resources and time, of course. Now for this guy, the user service test, let's have a look what we need to change in order to make it work. I'm just looking at my notes as well. That's why you see me going back and forth a little bit. Alright, so the test dispatch is checking this. Okay. Well, we're missing the token here, don't we? So user ID equals user ID. Let's get the token equals this get user token. This comes from the testing suite. It's the method that we added. If you remember here in the abstract test unit case, we just added a method to get a token. And also I need user transport equals transport new user db user. Okay, so now that I have this piece of information, I need to inject here HTTP authorization bearer equals token, and I guess this should be fine, shouldn't it? Do I need this user transport here? No, I don't actually. Alright, so let's send this again. Now that we do have the token, and lo and behold, it executes just fine. So you can see how we're tightening the application right now, and how we're making sure that everything is as efficient as possible. This has been our goal since the beginning, to create an application that is as efficient as we can. It's certainly not perfect, and might suit your needs or might not suit your needs, but this is what we're trying to figure out here. How can we make this application as fast as possible and as efficient as possible and easy to understand and comprehend, right? So we got this validate token presence middleware. Let's put one more, and that one will be to check the structure. Okay, so this one is a test. Let's not make the same mistake again, and we're gonna clone this. Validate token structure. All right. Validate token structure in the container. It is this one, and let's import it. Perfect. In my routes enum, it's gonna go after this. Remember, this is the order that they execute. So in the structure one, what we're going to do is we're going to make sure that the actual token is validated, is valid. So the JWT class will come into play here. This is the one that we need. All right, so first of all, we're going to need the request, of course. We're going to need the env, of course, again. And we're going to need a JWT class, a JWT token. There we go. Now that we have this, what are we going to do? Now we know that the token does throw exceptions, so we need to have a try catch. And then what we're going to do is we're going to hold it there. There we go. And for this, for the error, it's gonna be actually an array of arrays, so to speak, and it's gonna be the ex get code and then ex get message. So whatever this one throws, we're gonna return the code and the message. Okay, so what are we doing in here? We need to token equals this get bearer token from header, and it needs the request and the env. And what we need to do here is we need to call JWTToken get object. Actually, we can put them together. Alright, so what we're going to do is we're going to get the token from the header, and then we're going to send it to the JWTToken get object in order to try and get a token object back. The Phalcon JWT parser will go through it and it will try to parse it, and if it doesn't, it will throw an exception. If the exception is thrown, it's going to be caught here, right? Of course, I don't expect any failures in the tests because we don't have any problems over there, but we still need to test the structure one, this middleware here. So let me copy this and its structure, and let me just completely copy the test over. Alright, so what we're gonna do here is we're testing different things. Hold on, let me just make a slight change here. I've noticed this before, but there we go. That looks a little bit better. Okay, so the different tests that we have to do, and it's all with regards to this middleware. And what I'm doing is I'm just saying micro and middleware. The setup test is this little method here that creates a new micro, throws the container in it, and then picks up the middleware from the container, and then it just sends it back. Okay, so we're getting these two variables up here. What we're doing is we're playing a little bit with the server variables, and then we're calling the middleware. And depending on what we have sent, then it will respond. So if we send this, it will respond not an array. If we send this, it will send you dots misalignment. But if we actually create an actual token, then we expect that the middleware will return true. So if I run the tests again, I made a mistake. Where? In the tests or in the code? Let me quickly check. Give me a second. Is it like this? I thought it was the other way around, but could be mistaken. It should be as a main array. Now it should be as errors are multiple. It should be like this. So this error that we see here, it's an array of something. Then this one is the correct thing and this one's the wrong thing, so the test is wrong. This needs to be like that, and this needs to be like this, because you could have multiple errors with exactly the same code, so we cannot use the code as the key because one will override the other. So tests passed, going back to our code coverage, refreshing, token structure middleware is spot on. Excellent. So the next one to put in our list is going to be the user one. So we have to check if the user is a valid user in there. Then we're going to check the claims, and then we will check if the token has been revoked. But that's going to be for the next. The token revoked will be for the next one. So let's go back to the token middleware again, structure middleware, and then what we're going to do is we're going to call it F5 validate token user. And of course we need to go to our container. Where's our user? It's here. There's our class. So now that one is there. We need to go to the routes enum token user. Alright. And now in the user middleware, what we need to do is we need to check whether we have an actual user or not, or whether this is correct or not. So for starters, we need the request, we need the env, we need the JWT token, but also we're going to need the repository, the query repository. Let's call it repository. Get shared service, container repository. And this one is a query repository. Alright, so what we're going to do is we're going to do this part here in order to get the token object. Now bear in mind, this one executed after the structure, so this one will not throw any exceptions. So let's call it get the token object. Token equals this. Now what I need to do is user equals JWTToken get user, and it will be repository and token. Remember, we have this in order to match the user in the database. And now this one will become if true empty user. Then you will halt the database, the application, and you will send in here HTTP codes enum app token invalid user error, and you're going to return false, otherwise you're going to return true, and that should be it. There we go. However, excuse me, in the code in the code coverage we don't have this covered. So let's create the test for it. I'm just gonna copy the test for you guys and explain the token user. Alright, again, same thing, we're using this setup test to get some stuff. I made the same mistake again here, didn't I? There you go, it's a little bit better. So we're trying to do a failure record not found. So what we're doing is we're sending a payload in there that doesn't exist. So it will throw an invalid user. And on the second one, we don't even need the token user here. We're gonna send the whole payload with the correct token, and it will exist. And of course, you have the user migration here that creates the user, then the user that comes from the database back, and then we're using that user to create our token, and then we're sending the token in. So if I run the tests, there you go. Again, code coverage, now it's full. One other thing to note here is we want to reduce database calls as much as we can, right? And if you notice here, the user middleware requires the database call. And this is the one that does it because it invokes the repository. So the question is there a way to keep everything as neat and tidy as possible? And that's a question that we're going to have to answer with our next middleware, which will be the claims one. And the claims middleware will be the one that will check every single claim that it exists. Yes, we did find the user in the database, but are the claims proper? Meaning the time, has the time expired? Is the same user ID? Is it the same token, and so on and so forth. So let's copy this and make this get token claims middleware, and we can just leave it here for a second. We need to go to container and just get the claims. There you go. Import it, routes enum after the user. Perfect. It's gonna run. So let's close this and close this. Close that. So the claims middleware, what does it need to do? Well, for starters, it needs to check whether the token validates. And in order for the token to validate, it needs data, user data. So if we go back to the JWTToken, if you recall here, down here, there's a validate method, right? That requires a user transport, and that's the actual user that we have from our database, right? The one that we got. Now here's the interesting part. We have already that user. We got him here, right? This is the user that we have. All right. Unfortunately, we cannot throw this user into the next middleware. So we got to find a way to shrink the number of queries, and we'll do that in a minute. Let's get the token claims first, just to make sure that it does work. So we need, of course, the request, the env, we need the repository, and the JWT token. Excellent. So we're going to get the token from here. We're going to get the user. So far this code is the same. And we need to, so this get user returns an array, right? This is a database user. And then what we need to do is we need to change this user to a transport. And to do that, we need to have the transport here too. Transport, and this one will be, there we go. So now that we got this database user, we need to say transport user, let's call it user. User equals the transport new user db user. All right, so we got that guy, and we need to find if there are any errors. This is where the JWT comes into play. Validate, will be the token with my DB user. Actually, I shouldn't have called this DB user. I should have called this domain user. And it is the domain user. There we go. And now in the errors, we just need to check if it is empty. If there's any validation errors that came back, then we're in trouble. And what we're going to do is we're going to return these errors back. Okay? Now, let's recap. So we're calling everything, we're getting these services here. We're getting the token again, the token object. And then it says this get bearer from header, blah, blah, blah. There is some calculation here for sure, right? Now, then we're getting the user from the token that hits the database. Then we're creating a new user, the domain user, and then we're validating. So this and this middleware are hitting the database. So you're going to have 2 hits per run for every request. And that's not something we want. But let's have a look. Let's see what the tests are telling us. All right. What is this? Test dispatch. Probably something wrong here. Why does it return an array of an array? Okay, well, we'll figure it out in a minute. Let's write the tests for the middleware, the claims middleware. Down here. Alright, let me just copy the whole file and let's explain. So what I want to do is I have this middleware here that I need to run different examples. So what I'm going to do is I'm using the data provider from PHP unit in order to make it run different scenarios. So if I'm creating a user with user token is ABCDEF, I expect to have validation incorrect ID. If the issuer is something, incorrect issuer. If the algorithm is different, the signature does not match. Same thing with the audience, same thing with the ID. I'll make a very quick pause here and I'll come back to because this test utilizes this set session user. I'll come back to this test in just a moment. Remember we said that the user and the token claims, these two middleware, are hitting the database at the same, well, one after another, and they're hitting the database for exactly the same user. So if we take the structure of this particular application, it will hit the user first, and then it will hit the claims, right? Again, I'm pointing at the tests, sorry. So it will hit this guy first, and then it will hit the claims. Now the question is, can we utilize something that it is in our container, which is alive in this particular run, in this request, so that we can hit the database here, the user middleware, and then store this user somewhere so that the next middleware can pick it up. And that will be only the usage, the only usage of that. And the answer is yes. We can utilize the transport in order to store some data in there so that we can easily pick it up and work with it. All right, so if we go to the data source, here and look at the transport repository, you're going to see that we have a new login user, which is a payload that is returned for our purposes when somebody logs in. And of course, we have a new user that is created with a new transport whenever we send a database user. Well, what we're going to do is we're going to store something here, which is going to be called private user transport as session user equals null. All right, and this dang it, we have to remove the read-only from this class, but it's all right. So this session user is going to be the user that is correct, that is found in the validate token user middleware. And the only reason we're going to dump it in there is because we don't want the extra query. So we need to create getters and setters, of course. So public function get session user, and it will be that, and then public function set session user, and it will be this. I'm pretty sure it's a void, right? Yes. Okay. So for this, let me just copy this here. Session user there. We need dbrega. Yep. And then this one will be, let me just copy the comment here. Okay. So we have these two in the transport. Okay. Now the ability exists to store a user transport, which is the outcome of this method, into one of this particular property, right? So if we go to the middleware itself, the validate token user middleware. All right, we've gone through this whole process and we reached this point here, and then right after that, if this doesn't validate, everything is fine. So this user is an actual user of the database. So we don't really need to do anything else with that. So what we're going to do is, if we're here, everything is fine, and we need to keep the user as a session user in the transport. So what we're going to do is transport equals application get shared service, and container transport, and we need to put transport repository. And here what we're going to do is transport set session user is this user. So we're going to throw this user here that we got into the session user. Reminder, if you do a JWT get, I got it wrong, didn't I? Is the set session user gonna, because this one accepts an array and the other one accepts something else. Let me quickly check the notes. Oh, yes. Now the set session user is wrong in the other implementation, but what we do need is we need to store it in this transport, and since it's shared, it will remain active, the same object, in the next part of the request. So the set session user needs to change a little bit. It's an array. Let's call it user here, and that one will be this new user. It will store a session it will store a user transport here. That was the mistake that we had. All right, so go back, new user, blah blah blah, and then token claims this. Once we reach this part, right, this thing here is redundant because we already have the user that was evaluated in the previous one. So all we have to do here is, all we have to do here is utilize the transport and just say session user equals transport get session user. And there you go. This user here goes in there, and this one validates. So we don't really need the repository here at all. And if you want, if we want actually, what we could do is we could enhance the repository as well, the transport repository, with one more option in order to reduce processing. So what we could do is we could do private token it's this, and it will be session token, and then it will be the same. Get session token will be a token here and here, and this one will be the get session token, and then the set session token will be for the token object. Session token equals token. Overlays the session token. Alright, so now we have session token, and actually let me reformat this a little bit. It'll sort everything automatically. Alright, so we got token as session token and user transport as session user. This one will complain. So the get session token gets whatever you have in here. The get session user gets whatever we have in here. When we want to store stuff into it, we're using the setters, and in our case we're passing in the session user a database user, and then we're creating a new user transport. In the case of the token, we're just putting the session token in here. So in the validate token user middleware, as this one will run first, we have this token that has been converted from the string that it is to an object, right? And then the user, and remember, this one is valid because in the previous middleware, the validate token structure, this part here did not fail, right? So what we can do even on this is, because this one is okay here, what we could do is we could just say token equals this, and if we reach this part down here, that means that the token is valid. It hasn't thrown any exceptions or whatever. So we could go back and pick up the transport. Where's the transport? Here. So we're starting from the presence. Everything is fine. We're going to the structure. Let me get the presence here, the transport here. We have this token. If this thing executes with no flaws, with no faults, no exceptions, then this token will be a valid object. And then down here, if we are down here, the token is an object and is valid. Transport set session token equals token. So we're setting it down there. And then the next middleware after the structure is the user. And we need the transport as well here. Token equals transport get session token. There we go. And we don't even need the request and the env anymore. And now with the user, down here we're setting the oh, there's the transport. I already had it up there. Sorry. There you go. With the user, because it's okay here and we've reached this point, it gets stored in the session. And now when we're going back to the claims, we have the transport. The token becomes transport get session token. The user becomes get session user. And we've just eliminated some processing time, and we've eliminated a second query for this. So once it passes this part, the claims middleware, then it's good to go. Let's run the tests for now. I know we have an error there, which I need to fix. We have many errors. Alright, so we made a mistake. Okay, token object must be of type Phalcon encryption security JWTToken. Alright, let's have a quick look. Validate token claims middleware test. I think I know why this is. It's because I'm testing the components one by one. Components, middleware. Where are we? Validate token claims middleware. Here. It's because I'm testing the components one by one. So this, when it starts playing around here, it hasn't run the previous middleware. It just runs this one. So this middleware expects not only the session user, but it expects the session token. So let's see, get user token will return a string. So we need to get a token object. Yes. Okay. Let's do this. JWTToken equals that. Okay, so when we go to this part here, we're gonna have JWTToken here. So get user token, this is our token, a string, and we need token object equals JWTToken. Get object of token. How do I do this? It should be fine. And then set session user, and then this one will be, it's It's not user repository, this is transport. Sorry for the mishap. Transport set session token equals token object. So if we run this again, we had 8 errors. Three errors. So what are we doing here? This validate token claims success. Okay, and this is on the one below that. We need to get again the JWTToken. Let's get this. Let's put it here, and then we're gonna do this, and it's gonna go here. So that should fix this test. So I expect one less failure here. We got 362. We got 272. That's good. Validate token user middleware test. There we go. Alright, failure record not found. Yes. Okay. 58 or 50. So it's here. This is a token. Token object equals that. Transport equals this container get whatever container transport session token equals token object. That should make it run at least once. So we had 272. Did this work? Record not found. So this test is failing. Shared 172. There we go. Excellent. So that one works. Let me just get these guys and then go to the success. Get for user this. Paste this. Token object equals that. Get the transport, set everything in there so that the repository transport is there. And then the next thing that we need to do is the claims. Why do I do this? Examples, user migration. Let's not do that. Let's do this container get shared this container get shared. Alright, let's run this guy. 172. At least we got the error out. So we got 7 failures, 2 warnings. So it says failure null is identical to array. It's not identical to array. Okay, let's have a look at this. We're making this shared, and it's fine. Validation audience not allowed. Incorrect UID. This is going to be from the claims. Middleware. Oops, there you go. If true is not equal to empty, source errors. So let's run this. 72, 7 errors, 2 warnings, and we're returning incorrect UID as that. Quickly check this. The halt, what does it do? It returns the errors as they are. Okay, so we're returning the errors here. Validate returns errors of integer. Let me just double click on this. It's the errors, okay. So it's this part that we have an issue with. So in the claims, if I remove this and I go like this, it should work. There you go. And if we go to the code coverage and refresh, we got 100% code coverage everywhere. I'm not going to bore you with running PHP stan. I can do that a little bit later. Of course, I need to tidy up a little bit the repo and some other stuff that we've done, but the key points that I want to make here before I close, and thank you so much for staying all this time, is for our routes.enum and this middleware, and I actually need to run a test. I need to create a test to test this. Because if you change the order of these, the application is going to break. So what we've done is what we discussed in the past, the onion, Shrek, onion, I've got layers and all that stuff. So every middleware that we have here is a layer that gets executed before our action. So clearly the middleware not found gets executed before. Right after that, if the help was requested, it gets transported back. Now the rest of it, the middleware validate token presence, that checks if the token exists or not, and if it doesn't, then it stops it right here. So it will stop on step 3, and then if the token has not been able to be validated properly, the structure is wrong, then we'll stop on step 4, and then if the user is not correct or the claims are not correct, we'll stop on 5 and 6. The change that we made here with the, was it on the presence? No, on the structure. The change that we made here is we took advantage of the transport here, this one, and we created two new methods to store in properties 2 objects. Because we know how this operation goes, it's one after another, and it's exactly the same request. We store this data into this transport. So take it as if it's a registry where we store some things temporarily just for that request. Well, in this case, what we're doing in this transport repository, we're storing the session token,
because the token was calculated here, it took some processing cycles to be calculated, and we don't want it to be calculated again because the next middleware, which was the user, was calculating it again. So the user now has this token, it saves some processing cycles, and then it does the database query. Again, once we pass through all of this and we come down here, then we're storing this user transport, this domain user, if you like, in the transport. And then when we go back to the token claims, now we can get both the session token and the session user from this transport object, our repository, and then validate whatever errors we have and just send it back to the user. So with these small changes, we managed to reduce processing times and processing cycles. How much did we reduce? I don't know, but if you have in two parts of your application doing exactly the same thing, then you can certainly appreciate the fact that if you remove that one part, you are going to have some gains. These gains are probably nanoseconds, if not less. But in the grand scheme of things, once this API starts working for our application or our company, then the multitude of requests that you're going to have per second, that tiny bit of a nanosecond or even less would actually pay dividends. So always program defensively, meaning sanitize inputs and all that stuff, but also program as if you do not have resources in your applications. By throwing memory in to make your application works better, that works in the short run, but in the long run, a good design will last you for a very long time. And with that, I thank you all for being here. In this one, we created a JWTToken class to handle JWT tokens. We created a little bit of a hybrid class in terms of cache, storing some things and putting a couple of methods to allow us to store tokens in the cache. We will talk about this in the next installment, where we're going to do the refresh as well. We played a little bit with the unit test case, reorganized the passwords, and added more cases in the HttpEnum. We did a refactor of the EnvManager class, which led us to change registrations in the container and so on and so forth. We removed the Hello World class because we no longer need it, and instead we added a LoginPostAction where people can go and authenticate and get a proper token, and that token can be used to retrieve data from other endpoints. Primarily it's the user get, and we added 4 new middleware that would allow us to control how the tokens are being sent and how the tokens whether the tokens are valid or not. Thank you all so much, and hope to see you on the next one.